Welcome to the session number 12 from the playlist of moving charges and magnetism. The topic is the magnetic field due to a moving electron. And based on this topic, I have selected one question from one of my reference book. And the question here is, an electron revolves in a circular orbit of radius r with a uniform speed v. It produces a magnetic field B at the center. So the radius of the circle is proportional to. So there are four options here and we have to find the correct one. Now this session is based on the previous session, that is in the session number 11, in which we have derived the equation for the magnetic field at the center of a current carrying circular coil. And the magnetic field at the center of a current carrying circular coil is given by mu naught I upon 2r, where r is the radius of the circular coil and I is the current which is flowing in it. And if the coil has got n turns, if the number of turns in the coil is say capital N, then the magnetic field at the center of the current carrying coil will be equal to mu naught Ni upon 2r. So this is the formula which we have derived in the previous session. So, in this question, the electron is moving in a circular orbit of radius r with a uniform speed v. So, it is producing a magnetic field B at the center. So, the radius of the circle is proportional to, so there are four options here. So, and we have to find the correct one. So, we know that Q is equal to IT, where I is the current, Q is the magnitude of the charge and T is the time. So from this relation, I is equal to Q upon T. So in the case of an electron here, which is revolving in a circular orbit, so the charge on the electron is equal to E, and if the time period of the motion of this electron in a circular orbit is T, that is say capital T, then the current will be equal to E upon T, where T is the time period. And now time period is equal to 2 pi upon omega. And again, omega is equal to V upon R. So if I substitute this value of omega in the equation of this time period, so T will be equal to 2 pi divided by omega is equal to V upon R. So this T will be equal to 2 pi R upon V. So the current due to this electron, which is revolving in a circular orbit, can be written as E divided by T. Now T is equal to 2 pi R upon V. This is equal to 2 pi R divided by V. And where V is what? It is the speed of this electron. So this will be equal to E into V divided by 2 pi R. So the current due to this revolving electron is equal to E into V divided by 2 pi R. Now we know that the magnitude of the this magnetic field at the center of a current carrying circular coil is equal to mu naught I upon 2r. So I will be using this equation now in order to find the magnitude of the magnetic field at the center of this circular orbit. So B will be equal to mu naught upon 2r and I is equal to EV upon 2 pi r. Okay, so this is the equation which I have finally got, and from this equation, that is B is equal to mu naught EV divided by, this will be equal to 4 pi r square. 4 pi r square. I can simply write R square is equal to mu naught into EV divided by B into 4 pi. So here the radius of the circle is equal to under root of mu naught into E into V divided by B into 4 pi. Now here we have to find the radius of the circle which is proportional to B upon V or V upon R or under root V upon B or under root B upon V. So from here we can say that since mu naught is a constant, 4 pi is a constant, E is also constant. This is the charge of the electron. So we can simply say that R is proportional to under root of V upon B. So the correct option will be C, that is under root V upon B. So in this question, the most important thing was the utilization of the formula, that is I is equal to Q upon T, and then we have used the formula for the magnitude of the magnetic field at the center of a current carrying circular coil, which was equal to mu naught I upon 2R. So by using these two formulas, we were able to find the radius of this circular orbit, and here from this equation, that is from R is equal to under root mu naught into EV divided by B into 4 pi, we can conclude that R is directly proportional to under root V upon B, and the correct option is C. So thank you very much for joining in this session. In the next session, I will be discussing about the Ampere circular law. I was supposed to discuss this topic, that is Ampere circular law, in this session, but I thought it wise to take up this question which was based on the previous session, that is session number 11. So till then, have a nice day. Bye.